At the very center of our galaxy lies one of the most extreme environments in the known universe. Hidden behind vast clouds of dust and gas, invisible to ordinary telescopes, the heart of the Milky Way contains an object so powerful that it controls the motion of millions of stars and bends space and time itself. This is the story of the galactic core, the story of Sagittarius A, and what is happening there right now. Part 1. The Hidden Heart of the Milky Way.
The center of the Milky Way is located about 26,000 light-years from Earth in the direction of the constellation Sagittarius. If observed with visible light, this region appears almost completely dark.
Thick clouds of interstellar dust absorb and scatter light, making direct observation impossible. To study this region, astronomers rely on infrared and radio wavelengths. Observatories operated by organizations such as the European Southern Observatory have mapped the galactic center with high precision. These observations reveal an extremely dense stellar environment. Stars are packed tightly together, far more closely than in our local region of the galaxy. More importantly, these stars are moving at extremely high velocities, indicating the presence of a massive gravitational source at the center. Part 2. The supermassive black hole. At the core of this motion lies Sagittarius A star, a supermassive black hole with a mass approximately 4 million times that of the Sun. It does not emit light directly. Instead, its presence is detected through the motion of nearby stars and the radiation emitted by matter as it approaches the black hole. One of the most studied stars near the center, known as S2, completes an orbit in just 16 years. At its closest approach, it reaches speeds exceeding 17 million miles per hour. The gravitational pull near Sagittarius A star is so strong that it warps space-time itself. Objects that cross the event horizon cannot escape. Matter falling inward is stretched, heated, and emits radiation before disappearing. This process is one of the defining features of black hole physics. Part 3. A violent environment. The galactic center is an active and chaotic region. Supernova explosions release enormous amounts of energy. Gas clouds collide, compress, and form new stars. Radiation fields fluctuate constantly. Magnetic forces accelerate particles to near light speeds. Temperatures in certain regions reach millions of degrees. Radiation levels are extremely high, making the environment hostile to life as we understand it. Despite these conditions, Sagittarius A star is currently in a relatively quiet state compared to active galactic nuclei in other galaxies. Part 4. The orbiting stars. The most compelling evidence for Sagittarius A star comes from long-term observation of stellar orbits. Astronomers tracked stars moving in precise elliptical paths around an unseen object. These orbits revealed that an enormous mass is concentrated within a very small region of space. This provided direct confirmation of a supermassive black hole. Researchers such as Reinhard Genzel and Andrea Ghez played a central role in these discoveries and were awarded the Nobel Prize. Their work transformed our understanding of the galactic center. Part 5. Current activity. Recent observations show that Sagittarius A star is not completely inactive. It emits occasional bursts of X-rays and infrared radiation. These flares are short-lived and unpredictable, suggesting that small amounts of matter are intermittently falling into the black hole. A notable event involved a gas cloud known as G2, which passed close to the black hole. Scientists expected a dramatic increase in activity. Instead, only modest changes were observed. This suggests that Sagittarius A star is currently in a low accretion state, but remains capable of sudden energetic events. Part 6. Evidence of a violent past. Although relatively quiet today, the galactic center shows clear signs of past activity. Large-scale structures known as the Fermi bubbles extend above and below the Milky Way.
These structures span tens of thousands of light years and emit high-energy gamma radiation. They are believed to have formed from a massive energy release at the galactic center millions of years ago, likely caused by intense activity from Sagittarius A star.
This indicates that the black hole has undergone periods of much higher activity in the past. Part 7. Magnetic Structures. The galactic center contains complex magnetic fields.
Long filament-like structures stretch across space, carrying charged particles at extremely high speeds. These magnetic filaments are unique to this region and are thought to be shaped by the dynamic environment surrounding Sagittarius A star.
Their exact origin is still under investigation, but they play a role in transporting energy and influencing particle motion. Part 8. Direct Observation.
The first image of Sagittarius A star was captured by the Event Horizon Telescope. This image showed a bright ring of glowing material surrounding a dark central region, representing the shadow of the black hole.
The observation confirmed predictions made by general relativity and marked a major milestone in astrophysics. Part 9. Time and Gravity. Near Sagittarius A star, gravity affects not only space, but also time. Clocks closer to the black hole run more slowly compared to those farther away. This effect, known as gravitational time dilation, has been measured using the motion of nearby stars. It is a direct consequence of the curvature of space-time in strong gravitational fields. Part 10. Possibility of life. The conditions near the galactic center are extremely hostile.
High radiation levels, intense gravitational forces, and frequent energetic events make the existence of life unlikely. Some theoretical models suggest that microbial life could exist in shielded environments, such as within dense gas clouds.
However, there is currently no evidence to support this. Part 11. Future Evolution. The future activity of Sagittarius A star depends on the availability of matter.
If a large gas cloud or star moves close enough, the black hole could enter a more active phase. This would result in increased radiation and possibly the formation of energetic jets.
Such an event would likely be visible from Earth as a significant increase in brightness from the galactic center. Part 12. The Role in Galaxy Evolution. Supermassive black holes play a fundamental role in the evolution of galaxies. They influence star formation, regulate energy distribution, and shape the structure of their host galaxies. Sagittarius A star is part of this larger cosmic system. By studying it, scientists gain insight into the processes that govern galaxy formation and evolution across the universe. The center of the Milky Way is a region defined by extremes. It is dominated by gravity, shaped by energy, and governed by physical laws at their limits. At its core lies Sagittarius A star, a powerful yet currently quiet black hole that continues to influence the entire galaxy. While it appears stable today, evidence shows it has experienced dramatic changes in the past and may do so again. Understanding this region is essential to understanding the universe itself. Subscribe to Infinite Science for more in-depth explorations of space, physics, and cosmic mysteries.